Okay, let's do this. So let's do first this slide. So I'm very happy to be there. Antoine too will introduce yourself later. So this is our talk, malicious use of Microsoft Labs. So we carefully choose this title. We will discuss that later on. So we work for PwC. We both are ethical hackers in the cybersecurity team. I'm 5 years of experience, Antoine is 2, and we both had to publish some talks to various conferences. Just a few words about our company. So you can see we provide a broad range of cybersecurity services, technical, not technical, whatever. So today, we are going to introduce what Labs is, how does it work, and so on. Then Antoine will explain the analysis that we perform on this solution, the exploitation part, and then I will finish with some recommendations on conclusions. So I think it's important to give you a kind of disclaimer. You will not find a very complex ADA screenshot with hardcore reverse engineering and so on. No, it's a very simple approach. There is no new CVE, no 0 day, so it's just a simple stealthy persistence approach that we discovered and that we discussed with Microsoft. And sometimes when conditions are favorable, we may be able to do some escalation of privileges on Windows. So let's begin with that. So LAPS or Labs tries to solve the local admin problem. I'm quite sure you all know what this problem is. When you have a Microsoft environment, then you may be tempted to have the same admin password on all workstations, of course, because it's more it's simpler and so on. But of course, that's a pretty bad idea. So as soon as you have an identical or guessable local admin password, then trivial lateral movement is possible. So Labs tries to solve this with setting a different local admin account on each managed workstation in the domain. And for this, another point with that is that it will set a password that is compliant with one specific policy, as well as automatically renew it and change it when it has expired. So it looks interesting, isn't it? Of course, we first started to do some Googling on trying to find out who already worked on that. And you can see that there already are a lot of great blog posts and a lot of great papers from those guys. We really advise you to have a look at those papers if you are interested in Labs. But you may notice that they are more focused on server-side issues, on privilege issues on the domain controller. However, besides this, Labs is well documented. So if you read the doc, you will understand a lot of things. When you read this, you will notice that, okay, this solution has a client-side component, and actually all tasks related to the password management are done client-side. So why not looking at specifically what's going on the client side? And this is just a graphical, I would say, in order to a graphical way to justify where our talk is about. So from left to right, it's just the epic pawning way of owning a Microsoft environment. So we start on the left with no access at all to the domain. On far right, it is you are domain admin and you can do whatever you want. So as I said, the other researches that we cite, their main focus, it's not their only focus, but their main focus is what happens when something is shitty with the privileges, with some ACLs and so on. But for today, we are going to focus on the part on one specific workstation that could be or that may be corrupted. So how does Lab work? Well, actually, it's fairly simple. So this is taken from the documentation, official documentation from Microsoft. And you can see top left that we have the Active Directory. And for each computer account that you are going to manage with Labs, you will have two attributes. The first one is the admin password, which is in clear text, and the password expiration time. So of course, the admin password is not readable by anyone on the domain. By default, it's only by the domain admin. And then on the bottom of this image, you will see the managed machine. with the component that is actually a DLL that will handle all the password management things and that will do some controls and so on. So I'm just going to explain quite quickly how it works. It works with GPO, so you know, group policy objects. As soon as you enable labs, then at each GPO update, the local DLL on the workstation will check the attributes on the domain controller to see if whether or not the local password should be changed or not. So if it is the case, it will generate a new one and then store this new clear text password on the domain, and after this, it will set that on the local machine. So it's quite trivial, actually, just that this DLL is going to do that and checking with the dates, what's going on, and so on. Yeah.
Yes. So basically, the computer needs to have right access to the expiration time and the password to update it, and also to can read the expiration time to see if the password must be reset or not. So basically, we can use authority system account to manipulate these attributes. So as a system on the managed computer, we can easily change the password of the attributes, and so bypass completely the policy Maxime mentioned. So it's such random password, and we can also update the expiration time. So for those who are curious, this strange value is it's 30 days converted in 100 nanoseconds intervals elapsed since the 1st January of 1601, something like that. So really strange timestamps. And so this was on the managed client. And on the server side, before messing with the attribute, the password is really complex, really random, expires in November. And after we messed with the attributes, the password is changed on the attributes and the expiration time also. But in fact, the real admin password is not changed. And in this case, it's still this if you want to use the password locally on the computer. So we decided to continue our researches. So in fact, just continue to read the well-documented documentation, and also made some Google queries. So the DLL on client side is named admpwd.dll. So if we Google that, we see easily that it was an open source project developed back in 2011 to 2012, and later adopted as labs since 2 years ago. And so first observation when playing with the GPUs, no integrity checks or signature verification is performed on the DLL, and the old solution is compatible with the labs. So basically we can just copy the old DLL, replace on our computer, and it works. So since it's an open source project, we decided to read the code and to exploit it. So we elaborated 3 scenarios: one post-exploitation persistence, and 2 elevation of privileges. For the elevation of privileges, it will depend on how labs is deployed and how the machine is patched. Sorry. And so both the password change and retrieval could be triggered by a lot of trigger, and we can recover the password by many channels. It will depend on where the attacker is, if he have physical access to the machine, or on the LAN, or on internet, and will depend also of other controls in the network. So for our POC, we decided that we want to appear as normal as possible, and we said that the attacker have a physical access to the computer. we want to have the password synced with the AD. So the password written in the AD is the same as the real local admin password. And so for our POC, we decided to have the simplest functionality. So we can bypass the expression time if a special flag exists. So in our case, it will be a file named backdoor.txt placed at a special location, and the password will be written in a file just near the backdoor, and so we will have the password at each password chain, in fact. And to be as normal, we copy the same properties of the new DLL, and we signed the DLL by using this project, Sictif. Basically, this tool allows us to rip the signature from a real signed binary and to paste it in another binary. But of course, if you check the signature, it's not the real signature, but it has a signature. So
I will just wrap up on this. You understood that, okay, Labs is one DLL that is present on the server. Then by just playing with the source code of the equivalent open source solution, while the previous solution that inspired Microsoft to actually use and define Labs, now what we have done is just, okay, since there is one DLL, we may benefit from some temporary admin privileges in order to replace this legit DLL with our own DLL, which is just backdoored in order for us to be able to retrieve the local admin password each time it changes or each time we want it. But then we would not need any more the admin privileges in order to trigger that backdoor, okay? So this is what Antoine is going to demonstrate now.
So basically, two computers. On the right side, it's the domain controller with the Labs fancy UI we see in the screenshot. And the left side, it's a computer. For whatever reason, we managed to have administrator privileges, authority system, so we can exploit a misconfiguration, a missing patch, whatever we want. This is not our scenario. Our scenario is real long-term persistence. So basically what I will just do is copy the DLL I have on my desktop. And so, yes, for curious, I'm not admin. Yes, USC prompt. So I will copy the backdoored DLL and replace the legitimate ones. Yes, so just replace the DLL. So now I've lost my admin privileges. No more privileges. And I will ask the computer to update its GPU as a standard user. GPU update, sorry. And so, as my password is not expired and I have not asked for a reset, password is not changed, it's still this one. Now, I want to have admin privileges. I want to perform some admin task. So I will plant my backdoor.txt file. Yes, and same as earlier, I will ask an update of the GPU for the computer. And yeah, magic happens. Some file, random stuff. And on the domain controller, if I update, I ask for to see the password for the W10 computers. It's the same things. And the things, in fact, just the locally standard. So yeah. And so now I have the admin privileges back. And if I leave my backdoor and I remove the password, I can update the GPO and I will have a new password despite the expiration time. And so once the backdoor is not present, since the password is not expired, no admin have made a requested a change of password. Password will not be changed. But if the password expire or reset admin side, so request was successful, next GPO update, password will be changed. So basically, every time a password will be expired or a reset from the admin, we will have the password on our file. And just I mentioned, it's our POC. We can easily imagine that this password will be sent to a CNC or other stuff to retrieve the password depending on the attacker situation. So Max?
Yep, thanks. So as you can see, we just replaced the official DLL with our own, which is backdoored, which we can use with many complex stuff in order to get and retrieve or to ask the password to be changed so that we can have access to it. Of course, we can imagine plenty of other ways to do it in a more stealthy manner, but that was just for our POC, okay? Before we move on to the next demo, let's just have a few words about how we could deploy labs. The first method is just to install it with the MSI package, as you can see with this command line. And another documented method is just to copy-paste the DLL on the local workstation and then register the DLL with its functions with the program register serving 32.exe. However, if you combine this with some bad practices, which of course happen on a big network and with lazy admins and so on, then those would allow some escalation of privilege. One point about escalation of privilege, since this is an MSI, if someday you find an old Windows 7 on a domain that is managed on the part of the domain, then you may be able to do some privilege escalation on stealthy privilege escalation by just using the backdoor MSI in order to replace the official one. So this is a known bug. It's not a bug about labs. It's a bug about MSC package and the ways they could be installed. But let's not spend too much time on this. I will let Antoine just do another demo. This one, it works on an up-to-date system. Just the mistake that has been done by the admin is to deploy the ADM pwd.dll from a user-reachable location. So of course, if we manage to replace it, then we could do the same kind of scenario, but then we will do our escalation of privileges.
Yes. So same configuration as earlier. It's actually the same domain controller. And on the left side, another computer. And so, as Max mentioned, in this scenario, labs have been deployed just by copy-paste the DLL. So the DLL is not likely to be on the default path we saw earlier. So basically, it's just a registry value we can get by PowerShell or just by browsing the registry that says where the DLL is. So in this case, it's C labs ADM pwd DLL. And so as earlier, I will just have to replace the DLL, but this time I don't need some admin privileges. I just have to copy the backdoor DLL and paste it to replace it. Yes, I want to replace it. Yeah, and so just like before, if I plant my backdoor up, And I just ask for an update of the GPU. And yeah, same as earlier. We have full control on the admin password. I did not make the full demo like earlier because it's really the same thing. But on this case, we didn't have to elevate it to our privilege is because the admin were lazy and just paste the DLL on a user writable folder. And so like, basically simple. Yes. So Max.
Okay. So what Antoine just demonstrated is that with this method, actually, it's quite stealthy because if we decide to generate a new password, then we can do it. And if we just want the password to be accessible for us without having to do any interaction, then replacing the DLL allows us to do it on the long term. So now comes the recommendation part. So, of course, you understood it. The main problem is that there is no validation of the integrity nor the signature of this DLL. So one way to do that would be, let's say, to use some awesomeness of PowerShell v5 and just do some calculation with the file hash, verify the signature correctly. However, since we are in some scenarios in which we have access to admin privileges or that the system is vulnerable to some EOP or whatever, then you might want to consider to read the paper of Matt Graber, who demonstrated that as soon as you have admin privileges, then you will be able to corrupt all the validation routines on a Windows workstation. So as soon as you have admin privileges, everything that will calculate hash, everything that will validate signature locally on the workstation could be corrupted, of course. And again, for those of you who think about a strict application whitelisting on Windows, that's the same. Matt Graber demonstrated that even in the context of very strict application whitelisting, it is possible to corrupt the signature verification and validation. So another possible recommendation would be to intensively monitor everything that will happen on the server side, because this is where the attributes are monitored, are changed. So, of course, you will have to enable some logging on your domain controller. I'm quite sure that all of you already done that. And one way to do it is to monitor the changes of the password. But since this password has some special attributes in order to prevent anyone to read it, then you would have to change the never auditing bit of the search flags of the attribute on the domain controller. But if you do that, of course, it would be a very bad idea, because as soon as you put that, then you will have the clear text local admin password that will show up in the logs. So if you are proper segregation of duties when operating your Microsoft infrastructure, then everyone that has access to the logs will be able to get all the local admin password on your environment. So it's maybe something you don't want to happen. The other option, the alternative, will be to monitor the changes in the expiration time on the domain controller of these attributes. But once again, since we are the owner of the local DLL, we could choose when we change the password not to change the expiration time, or the other way around, to mess with it so that we can just mess with the admins on the blue team, basically. Another alternative would be to monitor on the client side. Labs provides such logging, but it is not enabled by default. You would have to change some values in the registry keys in order to log everything. So that's nice, but that's the default, and that's with the regular DLL. If we prompt our own DLL, once again, we could decide to ignore this setting and to log whatever we want, to erase the log or on anything else, just to remain still stealthy. So as a conclusion, Labs seems to be a convenient way to solve the local admin problem that every big infrastructure would face. But since it is designed with simplicity, with simple attributes and some rights, then sometimes it's not bulletproof. And if you combine this with admin mistakes and operational mistakes, then it could be critical, actually. Finally, for those of you who are familiar with some stealthy persistence technique, what we just demonstrated is some alternative of Mimikatz Mimilib that will be used as a malicious security support provider. So if you want detail about that, I invite you to read this nice paper. We will keep just in mind that it's not written like that in the paper, but it works in a local admin scenario too. So our contribution is with providing some DLL that looks a lot like the official one, but just do something that is in our interest, as opposed to Mimilib. And finally, detecting our tactic could be quite complex, because if you rely on monitoring, on correlating logs on the servers, on the workstations, then you will have to do it on all workstations, and you will have to consider that your workstations are not already corrupted, which is questionable if some people manage to get admin privileges. So in terms of future work, the initial creator of Labs continue to work on his own solution that is currently selling, I guess. He called that ADM PWD.E for enterprise. And there are some interesting features in this, such as the maintenance of password history, the encryption of the attributes on the domain controller, on some other goodness. But this is something to follow. And for some of you who would like to have the feedback of Microsoft, because when we found this, when we wanted to discuss that with them. So for the first scenario, the stealthy persistent technique, considering that we need admin privileges already, it's normal, we expected that they are not considering that as a vulnerability that they will fix. So actually for the persistence, it is still a valid method that you would use, because Microsoft is not going to do anything about that, which is normal according to their current threat model on strategy. And then I think it's the humble moment, because when we were working on the MSI repair bug, we thought that we found a very interesting zero-day crazy stuff that would work on every Windows system. Actually, we kind of messed up with our VM versions, and we spoke about Microsoft about a problem that they fixed like 3 years ago. Yeah. So yeah, shame on us. More haste, less speed. Another point to conclude, because we really want to thank Microsoft on the Security Response Center, because they were very kind with us, even if we screwed up some versions on some emails. Actually, Jason, our contact, even suggested that the engineering team would review the slides in order to give the feedback and just to correct some things. So I think it is something very interesting that I wanted to share with you in order to encourage you to discuss with them, because they are available and they really are willing to help, actually. Yeah. So yeah, thank you, Jason.
Thank you, Jason.
If you read that.
Yeah.
Thank you very much. We are now ready for your questions.
Thank you.
Okay, so questions? No questions? Okay, well, you guys will be around if people want to.
Sure, of course. We'll stay there.
We'll be around. Okay,
thank you so much.
Again. Thank you.